Question 3 to tutorial 4. In this question, we have two bases I use to support a platform. Bases here and platform. The center of gravity of the house basis platform system is known to be 0.5 meter above the water surface. This one is water surface, so center of gravity 0.5 meter above the water surface. You have to find whether the system is stable. With this one is 0.5 meter, B is 2 meter, C is 1.5, C 3 meter, and D is 1 meter. Okay. So, firstly, to determine this one is stable or unstable, you have to know where is central of gravity and where is the central submerged volume. And from the question, you know Z is 0.5 meter above the water surface. So now you have to find B, the centroid of the submerged volume. And submerged volume is this one and this one. So the centroid of submerged volume B will be below the water surface. And the distance from B to the water surface will be is half of D, or 0.5. Okay. And when B below Z, this one is to determine this one is stable or unstable, we have to find Zm or Mz equal to Iyy over Vs minus Zb. If this one is positive, stable. If this one is negative, unstable. Okay. And firstly, we have to have a look in the cross section between the system and the water surface. I call this one is A, point A. This one is point B. This one is point C. This one is point D. This one point E. This one is point F. This one is point M. And this one we have point N. Okay. So the cross section between the system and water surface, when you see in 2D, it will be like this. With A, B, C, D, and E, F, M, N. So we have to determine this system is stable or unstable in two axes, XX axis and YY axis. Okay, so firstly we have to look in XX axis and we have to find MZ. MZ in XX axis will be equal to Ix over Vs minus Zb. Okay, with Zb is the distance between Z and B. Z 0.5 meter above the water surface and B 0.5 meter below the water surface. So Zb, this one will be equal to 0.5 plus 0.5, or we have is 1 meter. Okay, Vs is submerged volume. Is the red volume you see on the screen. Yeah, this one and this one. So for this volume, we have V sub will be equal to 2 times, because the volume in the left hand side equal to the volume in the right hand side, times D times W times C. Okay, or equal to 2 times D is 1, is 0.5, and C is 3. So this one is 3 meter cube. Okay, so now we have to find mz x, sorry, ix. Okay, ix, we have to look in x direction, and to find ix we have to use a document, a figure in the lecture slide, this one, to find ix. However, as you see, the x axis go through the centroid C here. Okay, but in this case if we use A, B, C, D, and E, F, M, N, it will not go through the centroid. Okay, so in this case, Ix, we can't use Ix of A, B, C, D plus Ix of E, F, M, N. We have to use Ix equal to Ix of A, F, M, D, the big one, A, F, M, D minus Ix of B, E, and C. B, E, and C. Okay. This means the big area minus the smaller area. And when we use A, F, M, D, and B, E, and C, it can go through the centroid of the area. Okay. So now with AFMD, we have a look in this file. We see parallel with XX is A, and the other side of the rectangle is B. Okay, so for AFMD parallel with X, we have A is AD and the other side is B. Okay, so Ix of AFMD will be equal to 1 over 12 of A is AD times B power 3, B is AF power 3. Okay, and similar for Ix of B, E, and C. Parallel with the XX direction is A, 1 over 12. A will be BC and B is BE. Okay, BE. With AD we have AD is the 3 meter. AF will be equal to AB 0.5 plus BE 2 plus EF 0.5. So this one is 3 meter. Okay. BC is C 3 meter and BE 2 meter. Okay. So from here we have Ix is 4.75, which is power 4. Okay, so we will have mg Ix will be equal to 4.75 divided by 3 minus 1, and so that this one is positive. Okay, and this one, when mg Ix is positive, the system will be stable in Ix exists. Ix exists. Okay, and similar to Ix, we find YY exists and MZYY. MZYY equal to IYY over VS minus ZB. Okay, IYY. And now it's YY. We have this one is ABCD, ABCD, and EFMN, and YY exists here. This one is YY. Okay, and similar to Ix, ZB, the same, is 1 meter. The distance between the center of gravity and the centroid of the submerged volume is constant, ZB, 1 meter. VS, submerged volume, the same, 3 meter cube. So we only have to find IYY. Okay, IYY. So in this case, you can do similar to when you find Ix. IYY will be equal to IYY of the big one AFMD minus small one BE and C. Okay, or you can use IYY equal to IYY of ABCD plus IYY of EFMN, because now you see YY direction go through the centroids of ABCD and EFMN. Okay, if we use this one of ABCD and IYY of EFMN, okay, firstly have a look in IYY of ABCD. We have equation for rectangle is 1 over 12 of A parallel with YY. A will be AB, the other side is B, AD power 3. Okay. And similar for IYY of EFMN, 1 over 12 A parallel with YY is EF times B EN power 3. Okay. With AB when is 0.5 meter, ADC or 3 meter, EF 0.5, and EN you have 3. So from this one you will have IYY will be is 2.25 amp power 4. Okay, amp power 4. And when we have IYY, you can find MZ in YY direction. Will be equal to IYY is 2.25 divided by VS 3 minus ZB is 1. And so that this one is negative. Okay, and when this one is negative, the system will unstable in YY direction. Okay, so summarize, this system stable in XX but unstable in YY. Okay.